Hey everyone, very good morning. I'm sharing my screen. Okay. So in the last class, we were discussing about the boundary value analysis, test case design techniques. Under that, boundary value analysis is completed. I hope I've given the complete notes for boundary value analysis. Have you taken the notes? I'm audible to all of you. Hello, hello, mic testing. Hello, am I audible?
Yes, sir.
Yes, sir.
Sure.
I hope, have you taken the notes for boundary value analysis or not taken?
Taken, sir.
Taken,
Taken,
right?
taken.
Okay. Perfect. So now let's move on to the next one, equivalence class partitioning. So this is also one of the test case design technique where we are going to divide the input values into three equivalent classes like valid and invalid, equivalence, equivalence classes. Like when we have a input values, for example, say there is a text field called age. So there is an age text field. So this age text field, it is going to accept the values between, let's say, like, so as of now, only one. Okay, so they have not mentioned anything. You just have to enter your age. This is a text field. So it can be anything. So they have not mentioned any boundary value like starting value or ending value. They have not mentioned any boundary. So this age text field. So then how are you going to test this? That time I'm going to apply equivalence class partitioning. Like one, okay, I'll try to apply the values. Okay, so valid. So between 1 to 100, whatever the value you are going to enter, this is valid. This is valid. Apart from that, if you try to enter, let's say, uh, infinity to 0, even we can enter like say 6 months or 8 months, 9 months, maybe like that, right? So we have that option. You can say up to 0.1, like 1 month old baby, like that you can enter. But infinity to 0, this is invalid. And then 100 to infinity, whatever the value you are going to enter, these are all invalid. Usually this is how the software will be built. Yes, there are cases people who are lived for more than one year 25, like 125 years, 160 years. That's a different story. But this is a usually common people who live the life between span of 1 to 100 years. So I'm dividing equivalence class partitioning, one valid, two invalid values, one valid and two invalid values. This is an example for equivalence class partitioning. And a similarly example when I'm working in the online, let's say, so I want to do online shopping. So there's an online shopping website. Shopping. Then the product ID will be there. Product ID. And there's a button here, submit. Okay. So now there are different products. Let's say when I enter the product ID 10, 10 is nothing but printer. 20 is nothing but scanner. 30 is nothing but mouse. So I have these products. I have these products. So when I know these values, okay, if I enter 10 here, I should get printer. If I enter 20, I should get scanner, like list of scanners. If I enter 30, I should get mouse. So this is a valid, fine. For this, I'm going to derive two invalid values. I'll enter, let's say 25. So do you have any product ID with the 25? Do you have any product ID with 25 here?
No, sir.
No, sir.
So you will get nothing, no result. You should get that. If I enter 5, so you should get printer. If you enter 5, you should get printer.
No. No, sir.
No, sir.
So these two are the invalid values. Means we are checking whether software is working or not. We are dividing into equivalence classes and we are testing it. Okay, take down heading. Equivalence class partitioning. Now you can ask me, so do we need to apply all? No, any one we are going to apply while writing a test case. So these are all the types we have. In this, any one we are going to apply. Equivalence class partitioning. It's one of the test case design technique. 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 Here, we are going to derive the, here we are going to identify 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 the valid as well as, here we're going to identify the valid as well as invalid equivalence classes. Example, let us take age text field. It is going to accept, it is going to accept it is going to accept a age between 1 to 100. It's going to accept age between 1 to 100. and we are deriving into three equivalence classes. Write on this. Just write one. Don't write point one. Just write one. Maybe less than one. Whatever you enter, it'll not be considered. Let's say it is going to accept only the positive integer. Positive integer. Completed?
Yes, sir.
Okay. And write other invalid values are example like -2. Other invalid values are for the each classes, other invalid values and values, other invalid and valid values for each class, other invalid and valid values, other invalid values and valid values for each class. Example, let's say -2. Example, -2. So look at here. That comes under this category. -2, whatever you have entered. Next, put a comma. Then 5. It comes between 1 to 100. No, that is one valid. Comma. Then put 15. Comes under this category. Valid. Comma. 101 comes under this category. Invalid. Etc. Then another example. Let us consider example of a shopping website with the product IDs. I'm just writing a shortcut invalid. You write it properly. Invalid. I'm just writing IV and V means valid. So you write valid number and these two are the invalid values. Completed?
Yes, sir.
Okay. Next, we'll move on with decision table heading. Decision table. Let's say I have a login page. I want to test. So it has got email ID. Let's say, okay, username, password text field, login button, and cancel button. Username, password, cancel button. So now we have to prepare one decision table to test this particular text field. How are we going to prepare? So usually if I want to enter invalid username, valid password, click on login. I should log in or I should not log in? Common sense
Not
question.
login.
Answer. I will not enter any username. I will not enter any password. Click on login. I should log in.
No, sir.
No, sir.
I will enter valid username, invalid password. Click on login.
No,
No,
sir.
not login.
Valid username, valid password. Click on cancel. I should log in.
No,
No,
sir.
No.
sir.
Valid username, valid password. Click on login.
Yes.
Yes,
Sir.
sir.
Logins.
So these values I have to test. Okay, we are going to create a decision table. Okay, so let us put some conditions. Let's say T means true. It might be a correct username, correct username, password. F means wrong username, password. E means error message is displayed. H means home screen is display. Okay. So I have these conditions. We have to test the multiple cases. We have to test multiple cases. I'll write case 1. Username and password both are wrong. Then the user is shown an error message. Both are wrong means you should get an error message. Case 2. The username was correct and password is wrong. I'll say but password. I'll say but the password is wrong. Or let's say password was wrong. The user is shown error message. This is case 2. Case 3. Vice versa. Username was wrong, but the password was correct. Next, username was correct. I'll say username and say username and password both are correct. The user is shown or user is navigated to home page. Username and password text field is blank. Okay, total how many conditions I have written?
7.
Seven conditions. First one is username and password both are wrong. Then user will get error message. Next, username was correct, but password was wrong. So by default error message. Username was wrong, but password was correct, error message. Both username and password correct, user navigated to home page. Username and password text field is blank. Means user is shown error message. Username was valid, but password text field is blank, so error message. Username text field is blank, but password was valid, still error message. There's 7 conditions. We are going to prepare a decision table. I'll put a condition. Conditions. I'll say R1, rule 1, R1, R2, R3, R4, R5, R6, R7. Then I'll write a conditions. Let's say I'll write a shortcut like username, username, PW, password, and output. Okay. So condition 1, you tell me username and password both are wrong. According to this, I'll use F. F. Password is EF. So what should be my output?
False, sir.
Look at this
E.
condition.
E, sir. E.
Very good. E. Okay. Another condition. So username was correct, T, and password was wrong. What should be my output?
E only.
Error.
E. This is F. And this is 2. Next T. What should be output?
Error.
E.
E.
Condition true and true.
All
What should
is to
be true na?
home page. Sorry.
H. Home page.
Which home page?
Next. Username and text field is blank. So by default, I'll say blank means false.
F. F. E.
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 Okay, any one is true, but other one is
E.
by default it's E. I'll just keep it in the top. And you can just put it in the bracket. Uh, this is just a blank because it should not be a kind of repeated scenario. This is for blank. Why? Because same condition we have already written here. False, true. See here, false, true, R3. It should not reflect like similar scenario. This is for blank. This is for invalid. Okay, so this is how we are going to derive, and this is how we are going to test. Okay, take down. Let us consider an example for decision table technique. Login page. Take down this, then I'll give a what is decision table notes. First, you take down this diagram with these conditions, then these conditions you take down. Then I'll scroll left, scroll right. You can take down the table later. Finish it fast.
Sir, in R5 also we have to take F as a blank, right?
Yes. Done. Done. Others, good to go.
Yes, sir. Sir.
Okay. Answer for a decision table. Decision table, it is also called as cause and effect table. CAUSE, cause and effect table. Here, we provide the different inputs to the system. We provide the different inputs to the system. And capture the output. Here we provide the different inputs to the system. And we capture the output. And we capture the output. And we capture the output. accept the output in the tabular form or tabular column. Tabular column. That is why we call it as cause and effect table. That is why we call it as a cause and effect table. That's it. Okay. Another example for decision table. That okay, when COVID-19 came, okay, so that time everybody were panic. So for the period of time, okay, after 1 year or 2 year, we have got a vaccination. So everybody got vaccination on first day itself, or there was a condition. Hmm? Everybody got
No, sir.
vaccination on same day.
No, sir.
Okay, when we got a vaccination, or like who got vaccination first?
Above 50 years age.
Okay, good. Anybody want to try?
No, sir.
Those who are working in hospitals.
Okay. See, there was a condition. First condition: people with age greater than 60, greater than or equal to 60, those are eligible. Then we got one more condition. After a month, or like after 2 months or 3 months, greater than or equal to 45 age, they are eligible. Okay, and with some conditions, let's say with clear history of diabetes, with a clear history of diabetes and hypertension, BP, hypertension. Same way with clear history of diabetes and hypertension. We got this. So now we have to build on software for the people who want to take a COVID-19 vaccination, because yeah, our information was entered in the COVID-19 vaccination website. So if you have that vaccination certificate, people they used to allow inside a mall or inside an office. There was a condition. So now for that we need a software we have to build. So this was a rule which they have given for vaccination. These are all the rules for the vaccination. Okay. Now let us build a software for that. No, I don't write it here. It's easy to write it in Excel. I'll go with Excel. Say age greater than or equal to 60. Age greater than or equal to 45. Okay, let's say age comes under this category. Yes. Okay, here I'll just leave it blank or just put on hyphen. Diabetes, he's not having any diabetes. Hypertension, no, he's not having anything. So expected output, he should be allowed to take vaccination or no? Hmm.
Allowed, sir.
Allowed.
He comes under age this category. Yes. Age here, no. Is he having diabetes? Yes. Is he having hypertension? Yes. But normal condition, not abnormal. Is he allowed?
Yes, sir, allowed.
Allowed. Okay, is he comes under this category? Yes. Age. Okay, is he having diabetes? Yes. But abnormal. Is he having hypertension? Yes. But normal. Is he allowed?
Yes.
No, sir.
Not allowed. Not allowed. Is he comes under this age category? Yes. Diabetes? Yes. Normal. But hypertension? Yes. Abnormal. Is he allowed?
No, sir.
Not allowed, sir.
Not allowed. Okay. Next, is he comes under this age category? Yes. Is he having a diabetes? Yes. Abnormal. Is he having hypertension? Yes. Abnormal. Is he allowed? Hmm.
Not allowed, sir.
Yes. Here. Yes. Abnormal. He is not having any hypertension. Hmm.
Not allowed, sir.
Not allowed.
Not allowed. Hmm.
Not allowed.
Let's say, yeah, I guess we covered almost all scenario. Any scenario is missing? Normal we covered. Normal, abnormal, normal, abnormal, 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 then abnormal, not. One more thing. Is he allowed? Hmm.
Yes, sir.
Yes, sir.
Yes, sir. Allowed, sir.
Here, allowed, right? Perfect. Same conditions. Want to apply next. This is for age 45. Take down this. Let us, okay, first to take down heading. Let us consider an example, another example. First example, login. Second example. Let us consider an example for Let us consider an example to build a software. Build a software that ensures that ensures that ensures only valid people should get COVID-19 vaccination. Only valid people should get COVID-19 vaccination. Just a second, I'm moving this recording. Okay, take down this diagram. Only valid people should get a COVID-19 vaccination. So the okay, with various possible scenarios. Wait. Only valid people should get a COVID-19 vaccination. For that, rules, right out. Next line, rules for vaccinations. Rules for vaccinations. Point number one. Only people with the age greater than or equal to 60 with a clear history of diabetes and hypertension. With a clear history of diabetes and hypertension. With a clear history of diabetes and hypertension. Second point, only people with the age greater than or equal to 45 with a clear history of diabetes and hypertension. Next slide. The different possible test cases, which is shown in the decision table diagram. Different possible test cases with the different possible test cases which is shown in the decision table diagram. Take down this decision table. Total we have written 18 scenarios. This is only test scenarios, but Instead of writing this, we write it in a normal words instead of following the table. This is just for your knowledge purpose. This is how also, like in this way also we can derive the scenarios. Let me know once you complete it.
Completed, sir.
Completed. Shall we move on? Others, good to go?
Just a second, sir.
Yeah.
Completed, sir.
Okay. Now I'll give an assignment. Okay. So whenever you go to any of the government website or any of the application when you're filling, so they'll ask you to upload a form or like upload your image. Let's say you're trying to upload one particular image. So like this, there will be text field, and here there will be an option to upload. Say upload a file. Like this, then one option will be there. The moment you click on upload, there will be a condition. Condition number one. Condition number one. You can upload wait. I'll write here. Condition number one. You can upload only .jpg format image. This is one condition. Second condition. File size should be less than 32 KB. Third one, resolution should be like example 137 into 177. This should be the resolution. So now for this, I want you to prepare a table like this, decision table. I'll give a just an option, like there are different cases you can write: case 1, case 2, case 3, case 4, case 5. And you can write here format, and then you can, okay, because here one is format related, another one is KB related, I mean size, another one is resolution, and then at the last output. So three conditions you can put here, and you give a different input combinations. You keep on changing, you will get more than 8 cases: case 1, case 2, case 3. You write out output. Okay, so when all the three formats are correct, then only it should upload. Remaining, it should not upload. Take down this example. Let us consider an example for uploading a file to a website. Let us consider an example for uploading a file to a website. Uploading a file to a website. Okay, let us consider an example for uploading a file to a website. And we are going to prepare a decision table for this. And we're going to prepare a decision table for this example. Write on this diagram with all the cases. This completes your decision table. Completed? Shall we move on?
Yes, sir.
Okay, I'll close this. I'll take a new one. So next heading is state transition diagram. I'll try to complete it so that we can move on. State transition diagram. So whenever we are testing any application, so every application has its defined number of states. Okay, when you enter the valid details, let's say you have a login page. Assume that you have a login page. Say this is a login screen. The moment you enter this, right, a login page, login page or login screen, the moment you enter valid username and valid password, you should get a error message or you should be landing on the home page. Answer. The moment you enter valid username, valid password, you should get a home page or you should get a error message.
Home page.
Okay.
The home page.
But if you enter invalid username and password, so you should get a home page or
Error
error.
message.
Error message.
Okay. Okay. Now let me write down this. Okay, the moment you enter the valid credentials, you are getting a welcome page. So I'll say this is a stage one. Stage one. Once you enter valid credentials, you will be going to the stage two or state two. You can say that instead of stage, let's make it state. Different states. Now I was in the login page, then I went to home page. This is, you can make it a state. Say state one. State one. The moment you enter invalid credentials, you are getting another state, that is state 3. You're getting an error message, state 3. So when we are testing an application, so when the application under test, AUT, means application under test, it will be having the different states, like it will be keep on changing based on the input behavior. The moment you enter the valid username, you are going to the home page. The moment you enter invalid credentials, you are getting an error message. The moment you click on logout from welcome page to, you are again going back to state 2 to state 1. So that is called state transition diagram. So when we are testing a software application, every software application, it will be having a different number of states, a finite number of states. So it is going to transit from one state to another state when you're like based on the user inputs. That is called state transition testing. This is also one of the test case design technique, and we verify whether application is behaving according to this diagram or not. Okay. That is called state transition testing. Take down, but I never used this, but this is just for your knowledge purpose. Through this also you can test it, because it is very clear, right, in the diagram. Okay, enter valid credential, then only go to home page. Enter invalid credential, it should go to error message. That's meaning. Write down state transition diagram or state transition testing. This is the one of the test case design technique. This is one of the test case design technique. When the application is under test, AUT, when the application is under test, it will be transitioning from one state to another state. When the application is under test, it will be transitioning from one state to another state. According to the user actions, it will be transitioning from one state to another state according to the user actions. According to the user actions. According to the user actions, full stop. Every software application, it will be having a finite number of states. Every software application, it will be having a finite number of states. Every software application, it will be having a finite number of states. Finite number of states.
Sir, applications it will be have?
Every software application, it will be having a finite number of states. Every software application, it will be having a finite number of states. In order to define the transitions. In order to define the transitions. In order to define the transitions. That's it. Take down this diagram. I'll stop the recording. Just a second. I'll be on mute. You can take down the diagram.